Right, well, hello everyone, and welcome to the latest in the Stormwater 360 webinar series for 2023. This one's a bit of a special one. We're joined not only by our technical director, Mike Hanna, but an overseas guest in Seth Brown as well, and we'll introduce him shortly. So for those who have been to our webinars before, you'll know the format. We run through the presentation and then there's a Q&A session afterwards. If you have a question at any point during the presentation, please feel free to type that into the chat section of the webinar in Teams. And then at the end of the presentations, we'll run through and talk through some of those questions. And from what I've heard in the setup and the discussions putting together this webinar, it should be quite thought-provoking with a good number of questions that we can ask both Mike and Seth. So a little bit then, and I'll just do this. A little bit then around introducing the webinar. We're in quite a varied landscape today in New Zealand for stormwater. There's chronic underfunding for councils for both infrastructure and implementation of that infrastructure, maintenance of existing and future assets, and also standards development and understanding how best to design what they're going to be putting in. And especially for manufactured treatment devices, which Stormwater 360 supply, each regional council needs to assess the performance of a treatment device in relation to the outcomes required by their freshwater management plan. And then they may choose to approve or accept a device based on how it performs. And then each territorial authority then needs to provide a product approval for use of that device. So there's variation in approach across the country. Each regional council, each council approaches things slightly differently. And all of this work is being carried out in double, triplicate, quadruplicate, it goes on. And what is really great to see from what we're going to discuss in this webinar is an alternative approach to a national testing methodology that has been implemented in the States. And I think there's a lot that we can take away and learn from that. Our first presenter, Seth Brown, is Executive Director of the National Stormwater Alliance in the States. He's a water professional with a passion for technical aspects of stormwater issues and policy and economic dimensions of this dynamic field. He has an awful lot of experience, and we're very honored that he's able to join us today at, I think it's about 8 o'clock in the States currently. So thanks for staying up. And Mike Hanna is well known within New Zealand. He is Stormwater 360 and Enviropod International's technical director. He works in New Zealand, Australia, the United States and Canada, and sits on a number of boards and technical authorities across all those places. So is in a great position to bring to us what is done overseas, but how that might apply to the New Zealand frame. So, as I said, it is great to be able to bring together both Seth and Mike. And so, Seth, it's over to you to talk about STEP and ASTM. Welcome. Kia ora.
All right. Thank you. Can you hear me and see me?
Can hear you great.
Excellent. Great. Okay. So I'm going to share my screen. Thanks. I appreciate that, Matthew. And can you guys, is everything looking good right now? You can see the screen? Okay, great.
Yep.
All right. Well, I'm going to kick things off. Okay. So good. My name is Seth Brown. I'm the Executive Director of the National Municipal Stormwater Alliance here in the States. And I just, I've known Michael for quite a while, just through various conferences and whatever. And I have not made it to your part of the world yet, but Michael makes it up here quite a bit. So that's the great connection. So Michael is a great leader in your part of the world. And I appreciate that. So I'm going to spend a few minutes, I'll just think 15 minutes or so to go through some slides, kind of talk about, I'll just, I guess, tell you what I'll be talking about. I'm going to give you first a little background on our organization and just to give you some context where we're coming from. But spend more time really talking about the STEP program, which is the stormwater testing program that I think we want to feature here. And then talked about the technology readiness and verification, the kind of the philosophy behind, or the basis of what STEP is, and then finally talk about what does STEP do, how does it work, a little more of the mechanics of it, not too much detail, and then some last little updates on that, and then I guess we'll have a Q&A after all of this is done. So, so that's the overview here. So before I get going too far, you know, again, the National Municipal Stormwater Alliance is the group that I set up in 2018. When I say national, I'm talking about national U.S. So we're a nonprofit. We're an alliance because we bring together state organizations. So, you know, of our 50 states and territories, additional territories, we've brought together about 25, about half of the country in the last 5-6 years. So it's pretty good for that amount of time. And we've got representatives from these different state organizations. So one that's probably most familiar to folks on the call here is the California Stormwater Quality Association. So that's an example, but you know, other states are part of that too. So the motivation for the formation here is just, I mean, I'm not going to go through this whole listing here, but the challenge here in the States is that our sector is fragmented. We've got different, you know, we've got over 7,500 or so communities that have some kind of stormwater regulation that they have to meet. MS4s is how we, that's our moniker for that, Municipal Separate Storm Sewer Systems, MS4. And most of those are small and mid-sized communities. So they're all over the country. Some are in suburbs, some are in large cities, but many are outside in the exurbs or even rural areas. So we formed this organization to try to help catalyze the maturation of the sector, try to unite it so it's not so fragmented, and then basically raise the image of and the profile of stormwater. And our vision is similar to many other organizations. We just want to help, you know, promote clean water and get that for our country and for our residents and citizens and families and neighbors and all that stuff. So anyway, you can see here's a map of the U.S. within the states that are in blue are the states that are members of our organization at this time. So again, we've got 25 states, over 4,000 of the 7,500 communities, and we've got communities that are joining us directly. So that's one way we're evolving. We also have many affiliate members. That's technologists, consultants, law firms, anybody who's kind of in the ecosystem of stormwater, and you know, Stormwater 360 is one of those affiliate members. So that's where I'm coming from. That's the group I lead. One of our programs, probably our leading program, is the STEP program, which stands for Stormwater Testing and Evaluation for Products and Practices. And it's the setup for this, or the motivation for this, is based upon a simple question, which is, how well do stormwater products and practices work? Well, first of all, take a step back. Products, we refer to products as proprietary, something that you buy off the shelf or have delivered to a site. It's a unit of something. Practices are public domain, something that you construct, buy a retention facility or a pond or something like that. But we need to know how all of these systems work, whether it's proprietary or public domain. So the question is, how well do they work? Well, of course, it's a rhetorical question, because how do we define well and work, right? That's something that could be seen as subjective. And every organization or every permit holder has to make those decisions themselves, but they need information to do so. And the problem statement that drives all of this is that there is no national organization in the U.S., at least, that provides this consistent and robust technical and objective testing information that so you can say, yeah, I understand how this product in many instances right now, hopefully will be going to the public domain side, but products right now, how well we have some confidence that we understand that this works in a certain way. Here they claim that it's this, we verify that it is that, and that's great, and we can move forward. That's really the motivation. There's a long history to this. I'm not going to go through all the details here, but you can kind of browse through this. But I used to work at an organization called the Water Environment Federation from 2010 to 2015, and during that time, we heard from EPA, our environmental regulator in the states, as well as from many in industry and many state regulators. So our programs, we have a federal program, we also have states that implement regulatory programs. At all levels, there was a clear need for something, a stormwater testing, product testing and practice testing program. So we went through the effort of investigating this. What's the feasibility? How would it look? We got some funding from the federal government, which was very helpful to kind of frame out how this would actually function. And then I left for various reasons and started NAMSA, and then eventually NAMSA, or the STEP program, went from the Water Environment Federation to NAMSA. So that's where we are today. And that's a relatively recent shift that's happened. So again, STEP stands for Stormwater Testing Evaluation Products and Practices, with the goal of developing this national program that does not exist right now. And the reason we want to do this is because we want to raise the bar. We don't want to lower the playing field. We want to have a consistent and reasonable but high playing field. If we don't do that, we're not going to make progress on clean water, and that's really what we're all trying to do. So these are not mutually exclusive. You can make money and have clean water, and hopefully one drives the other in a significant way as we move forward. But to do so, you really need to have a value proposition that there's got to be confidence from those who invest in this, our ratepayers, our taxpayers, or those who pay for ultimately the use and the services associated with our stormwater infrastructure. They need to have confidence in the performance of all of this infrastructure. I guess I think about it in the fact that you would not expect someone to build, or a state or a public agency to build a bridge and not expect it to perform, right? Why would we do the same thing here? It's public dollars, it's an infrastructure sector. We should want to do that. If we can do all of that, then we can have improved water quality. So that's really the goal. Where it sits in NAMSA, the National Municipal Stormwater Alliance, is the National Center for Stormwater Testing and Evaluation, and I'm the director of that. And a person named Jay Holtz is the chair currently. Jay's with Oldcastle Industries, and the chair is a rotating position. So every 2 years that rotates around. But this is really where the STEP program functions. So the principles behind the STEP program are pretty straightforward. We want to reduce the cost and the time for products to get to market, but we want to do that in a way that provides the confidence, again, on performance. To date, it's a costly and arduous process for new products, especially new innovative products, to get to the market. So that means that smaller technologists are often crowded out. And so it's a barrier to innovation. We want to reduce that barrier. We want to open up markets, but we want to do so in a responsible way. There's 2 programs that here in the states that reside at the state level. There's the Washington TAPE program, which is Technology Assessment Protocol for Ecology. That's the regulatory program. So that's in Washington State, and that's a field testing program. Then there's the New Jersey Corporation for Advanced Technology, or NJCAT, and that's a primarily lab-based program. It's got more than that, but that's primarily what it's known for. Our idea is that we're going to leverage these 2 state programs to provide nationwide coverage, potentially North American and potentially international coverage, depends on where things go. We are focusing on verification, not certification. I'll talk about that in a minute, and I won't get into that at this point. We've been spending a lot of time here in the U.S. recruiting states and communities to get on board, start pointing to our program, even before it's functioning, really, because we need to provide a good sized market for technologists to invest in us. So if we have 20 states in a big market, then it's worth product manufacturers to invest in our program and become part of it. That's what we've been working on. And I'm not going to go through all the details on all of this, but we can cover that if there's any questions. So I did want to transition real quickly over to what technology readiness and verification is in the context of what we're talking about for verification and why it's important. There is an approach called technology readiness levels, TRLs. I believe that something that it's a paradigm that NASA put together back in the 60s or 70s or something like that. Basically, how do you go from basic research, R&D, to full implementation into a market, or something that's ready to be, to put into play? And the idea, if you look at this graph, what we're looking at here on the y-axis is the level of investment as you move along from 1 to 9, from this basic research all the way out to deployment of a technology. And early on, through the early basic research, applied research, those type of areas, basic research areas, it's primarily, you see a lot of investment by academia. Later stages, as things are getting close to deployment, it's industry. In between is that valley of death that's often talked about, which is no one's really taking ownership, and that's really one of the places that verification programs like STEP play a role. So that's where we hope to be effective. And there's other ETV programs out there. Europe's got one, Japan has one. There's an international ISO 14034 is an ETV type of system. Basically, it's an approach that provides verification for performance claims. That's really what it's about. So it's not judgment on our part. We're just providing the platform to say, hey, you say you performed a certain way. We're going to go through a methodology to verify or not that claim, and just say, here's what the information is. And really a basis of this is having independent third-party reviewers and standardization, and that's something that Michael's going to talk about in a little bit. So I don't want to get too far into the weeds on that. So what does STEP do? How does it work? It's pretty straightforward. I talked about how we are focusing on verification, which is the left box here, not certification. The reason for that is that certification implies approval for use or certification for use in a jurisdiction or an area. Our organization doesn't have a permit. We can't really approve for others. It's up to a state or a community who holds a permit and says, here are our performance standards. To be used in our community, you need to be able to get 80% sediment removal, for instance, or 50%, or whatever it is. That community, each community has their own ability, and state has their own ability to say what their requirements are for performance. If the verified information that we're providing through methodologies that provides more confidence and saying, yeah, I think I know I understand. I know I have better confidence in understanding how this actually performs. Based upon that information, I will certify or not certify in a jurisdiction or whatnot. So that's the difference here. We're a verification entity, not a certification entity. Just want to make that clarification. As I mentioned before, we're looking at products and practices. So our initial focus is going to be in that top box, focusing on proprietary products here in the U.S. at least. And in Canada, that's a very similar dynamic, which is there's a requirement by many jurisdictions, most jurisdictions and states throughout this country, that if you're going to use a product, it has to be tested and shown to perform. But that same requirement is not true for constructed practices, public domain practices. We are going to try to change that. We're working with researchers to develop testing standards for things as basic as bioretention facilities, ponds, and whatnot. So that's when we hope to transition from just focusing only proprietary products to public domain as well. And as we go along, we'll have a full portfolio of testing standards for hopefully the larger portion of the universe of stormwater infrastructure that's being used out there. And that's going to take some time, but that's our pathway moving forward. Looking at actually how STEP actually works, it's very straightforward. You just have a representative of a product or practice that submits an application for verification or re-verification, but we're probably just only going to have verification initially at first. And then at STEP, we will go through and make sure that there's a quality assurance plan. We'll make sure that the right testing standards are going to be done. And I'm not going to get into that because Michael's going to talk about ASTM standards, but that's what we are relying on is the ASTM program. We'll make sure that testing is done the right way. We'll verify it. We'll use objective third-party outside reviewers to do so, and then we'll write up all the results, and then we'll store that data, and we'll provide the verification report to the representative. They can go request certification for use or approval with any state or locality or any other interested party. They either get certified or they don't. And that's the basics of. There's much more to it than that, but those are the basics. Our governance is set up with having a leadership council. We don't have a board of directors because we're a subset of an organization. So you can't have two boards within an organization. So there's going to be a leadership council that will make strategic decisions. We'll also have a technical subcommittee and a stakeholder subcommittee, so we can make sure that what we're doing is meeting the needs of the sector. The technical committee is going to make sure that we have all the ASTM standards that we need to have. And if we don't, we need to start developing them. They take some time. And then, of course, STEP staff is me, and then we've recently hired a part-time person, and we've got this board of external reviewers. Those are the third-party specialists, oftentimes PhDs, professors, and/or PhD students, whatnot, who will provide the objective review of this information, and they'll be conflict free. They provide information to the STEP staff, and we all put together the information that's then provided out to representatives. So anyway, just real quickly about engagement outreach. We spent a lot of time doing this, engaging with in EPA, our regulator, with a bunch of states that are very interested. We've got a good critical mass of states here, as well as municipalities. So we've been building a lot of demand as we move forward. And we've also been working with other industry groups and sector groups as well. So a lot of engagement and outreach has occurred. One example of this is we did a national survey of MS4s. Again, those are cities or communities that have regulations, as well as states. We wanted to see how each of them thought of issues or rely on testing programs. And we asked the questions, do these entities currently rely on a testing program? Most do, but many don't as of now. We asked them, if a national program were to be established, would you defer to it? And close to 80% said they would. So there's clearly demand for this. There's clearly interest in doing something like this, that we felt like we're on the right path. We asked about, should they be lab-based testing or field-based testing, or both? We provide both, and it's up to the states to use whatever they want. And sure enough, the states and the jurisdictions both said, yeah, we want to rely on both of these types of testing. So we feel like having that flexible approach is something that is going to be seen as attractive. We also asked about what are the biggest issues in terms of pollutants and prioritization. We see that for communities, trash, and I'll bring this up for a specific reason. Trash and gross solids that are leading to plastics issues and microplastics and whatnot is a big issue for localities, but it's not for state regulators at this point. And that means it's primarily a local issue at this time. And that's something that's consistent that we see across this country, but it's becoming more and more of a regulatory issue, I believe, and it's going to continue that way, because there's more and more research that shows this is an issue. But that shows that there's interest in doing this, even if it's not heavily regulated. So our first pollutant of interest that we're starting our program off with is trash capture technologies. So that's we feel like there's an inherent motivation that already exists at the local level, and it's only going to grow with more regulations that we see coming down the pathway. As far as how we were launching this program, we really started ramping up the launch in 2021. That was our development phase. We're in a transitional phase this year and next year, and then we hope to be fully operational by the mid to end of 2025. So just so you know where we are in our pathway moving forward. And lastly, I'll just talk about a couple updates that we've had. This year, it's focusing, like as I mentioned, on trash capture technologies. We're going to have what's called a soft launch, or a limited launch, basically right now or between now and the end of this year. We're really putting together the final touches on our governance. So this is the takeaway here is that we are about ready to start turning on the lights. We're hiring up staff and whatnot. We have the survey that we've had that illustrates there's high support and need and demand for STEP, and we're continuing to engage with states, MS4s, and others. And we're starting to see the potential for up to $25 million of funding from our federal government over the next 5 years for these centers of excellence for stormwater testing, something that our organization advocated for, and our recent passage of the what's called the infrastructure bill in our country. It's one of the most significant investments in infrastructure we've had in generations, if not beyond. So stormwater is getting seen in that context, which is a great win for us, and we hope to be able to leverage some of this funding to kickstart and grow our program. After starting with trash capture technologies, we're going to be focusing on sediment reduction and sediment treatment technologies. That's going to be in early next year, based upon lab testing only, which covers a big swath of the requirements and demands anyway. We're going to continue to develop field testing programs. Many states and jurisdictions require either field testing only or field testing and lab testing. So we're not going to be fully functioning until we get field testing standards developed and integrated into our program. And we've developed a fee schedule so we can officially get states and jurisdictions on board. That's happening right now. And we're going through fundraising right now. We actually wrapped up our phase 2 fundraising, which has been great and has been more than successful. and we continue to have more and more interest from states and jurisdictions as this becomes more of a reality and not just something that we talk about. So anyway, that was a quick run through of where we are, what we're doing. And I don't think we have time for questions right now. I guess we're going to have a Q&A session at the end of this. Is that correct, Matthew?
Yeah, that's correct.
Okay.
Thanks so much, Seth.
Yeah, I'll stop sharing then. So I'll pop it over to you, right?
Yeah, it's great to hear some of the similarities and some of the differences as well. With some of the similarities and some of the differences between both the States and New Zealand. A lot of what you said, there was a lot of what you said had, Mike and I were looking at each other going, yep, that's exactly the same as in
really?
same as New Zealand. So
there we go.
So now to place that and to talk a little bit about the testing, but to place that in the New Zealand context, over to you, Mike.
Cool.
Just share.
I'm gonna shut down, and then when Q&A happens, I'll pop back up.
Perfect.
Great. Awesome. That's a great introduction from Seth to talk about the overall STEP process and how they verify technologies. I'm going to dive a little bit deeper. I'm actually going to talk about the actual standards and the testing methods. ASTM is an international testing body, and with the group and STEP committee members and all interested parties, we've developed a whole bunch of testing methods for different stormwater control measures. I'll jump into it now. How do I move to the next?
Yep. Should do it.
Here we go. Yeah, so I just first I'm going to talk about the ASTM and go through that, but then at the end of my presentation, I'm going to have a bit of a discussion or a reflection about how we can bring these testing standards and evaluating standards to New Zealand. As far as the ASTM overview, I'm going to introduce standards. What are they? Why do we have standards? I'm going to look deeply at the ASTM's process and how a standard is developed. Then we're going to actually dive into E64, the Stormwater Control Measures Committee. This is where all the work is done on the actual stormwater standards. And then I'm going to go into looking at what standards have been completed and what standards are in progress. Now, this is an ongoing thing. There's probably going to be no finish line, but this is just where we're at the moment. So my background, I guess you guys probably know me. I'm the Technical Director of Stormwater 360 in Envirobod. I've just been made an honorary life member of Water New Zealand, which I'm very proud of. And you know me from around every conference we have in New Zealand. I'm also a volunteer of ASTM. All the members of ASTM are volunteers. It used to be only $75 US a year to be a member and contribute and get access to a whole bunch of standards and the development of standards. Now it's $130 US a year, but that's really not a lot of money for what it gives you. I'm also, as Seth mentioned, I'm a member of STEP, NATSTA. I'm also a member of SIA Australia and the Water and Environment Association Ontario in Canada, as well as the International Water Association. So this gives me the experience of dealing with stormwater in so many different countries. And really, stormwater is stormwater. Different countries look at it in different ways. They have different contaminants and they have different characteristics of stormwater, but the issues are still the same no matter where you are in the world. So as an introduction, modern stormwater management, it's not a long science. It's only really about 50 years old. I think the National Stormwater Day is coming up soon, which is a celebration of when the first MS4 requirements came into the States, which is really the first stormwater regulations to be placed on an area or a city. Stormwater is really difficult to manage and really difficult to predict because it's so highly variable. It's as variable as rainfall, and if anyone can predict rainfall, well, they're doing pretty well. So it's a difficult thing to manage. our current level of understanding of stormwater, and this might be a bit of a controversial thing, but our current level of knowledge on stormwater management isn't really sufficient for us to prevent degradation of our urban waterways. And that's a real challenge. There's a lot of modelling work, a lot of assessments been going on at the moment in New Zealand, and really we can't get the water clean enough to be as where it needs to be unless we have some innovation and advancements in the technology required. So this is why this is so important. So what's a standard? A standard's an agreed way of doing something. It could be a product, it could be a process, it could be a service, it could be many, many things, but it's a standard way, a repetitive way of doing something. Standards also provide wisdom for new people or new or associations coming into an area, a subject area, and because the people working on standards are experienced experts and they give their knowledge freely to develop a really robust methodology of looking at things. Standards provide a better platform for understanding through this engagement and collaboration by all stakeholders and all experts, and that leads to continual improvement. So standards are really the way we overcome a lot of our problems. So why do we need them? Well, obviously I've just said what I before, but a standards organisation emphasizes openness and transparency. It's really inclusive with everyone who's got an interest in it. It's not just, say, a regulator saying, well, we must do this, or a supplier going, oh, we must do this. It's collaborative. Everyone must work together with a standard and get consensus, because really no idea is a bad idea. As I said, it's open to regulators, it's open to businesses, it's open to industry groups, and even an individual that is concerned about stormwater can join E64. Standards are unbiased because they're collaborative and they're open. There's not one person might say, well, this is a better way, and they must convince the group and work with the group to get a solution. Standards also really support evidence-based decision-making, and that's really what we need to create better policy, around environmental policy in particular, in this country and across the world. It enhances, by having a method or an approach, it really enhances innovation. For instance, if I was wanting to develop a stormwater treatment device and I had heard that sediment was a problem, I could go out and start testing a product on sediment. But is the sediment I'm testing it with the right sediment? Is that similar to stormwater sediment? You wouldn't really know unless you've got some guide, and that's what standards have. They allow you to focus in on what's really important because there is a guideline and a set of procedures to test to. Another reasons why standards are important, or why we have standards, is that if there is a way of proving your technology or proving your product or proving your solution, that means you can gain investment to develop it. Without any clear pathway to get a return on an investment, you're not going to get investment. So having a pathway is really important for getting the funding that we need in the private and the public sector for developing better solutions. Standards provide consistency and fairness. As I said, that collaborative approach definitely provides fairness, and it provides consistency. So if you're using a standards-based approach, it's really unlikely that you'll be in front of the ombudsman or a judicial review or anything like that happening to you, because it's been inclusive of everyone. It establishes best practices, and it really facilitates the knowledge exchange. Now, I'll get into these standards, but if anyone on the call here wants to develop a stormwater treatment device, the standards are a great way to start and learn all about what you need to do to develop a technology. So it really facilitates that knowledge exchange. What aren't standards? Now, this is really important. A standard isn't a pass or a fail. It's actually more the methodology, the testing approach. It's not a verification, and Seth talked about a verification. A verification is where you review a test and you make sure it follows the methodology or the approach in the standard, and you can stamp it, it's verified. It's done the test correctly and those results are correct. It doesn't mean it's an approval, and an approval is what a certification. And then that, as Seth has said about STEP, is really still left with the regulator or the city council or the states in the US or whoever is in control of the water body. They have the right to say, yes, okay, we've seen the verified results. Now we're going to approve you. But, we're going to put a condition on that. We're going to put a condition on that you need to inspect it every 6 months. Or they might go, well, we've looked at the verification results. That sediment that you were testing in, that's very coarse. Our sediment in Christchurch is a lot finer. So, I don't think that verification is suitable. So we're not going to approve it. Just as by an example. So a standard is a standard. It is the method of testing. It's not the verification or the certification. So moving on to ASTM, well, originally it was called the American Society for Testing and Materials. And then they, a couple of years ago, about maybe 15 years ago, they added the international part on it. So now it's ASTM International. There's about 12,000 different standards, and they cover nearly everything in this world, from electronics to stormwater treatment devices to cars to anything. There's 12,000 standards on all sorts of things. The ASTM process, as I said, it's consensus-based. We all must agree before it becomes a standard. All the stakeholders must agree. Because of this consensus, it's a higher standard than maybe one individual or one organisation developing it themselves because of this collaborative approach. ASTM also improves the performance of safety in all the products it does, and it also gives confidence to the consumers, the buyers, the people spending the money on those products or those technologies that they will do what they do. Down the bottom here is a link to the standards and the ASTM standards. So when you get this PowerPoint, you can link through and have a look at them yourselves. So how's a standard developed? Well, first there's a need. Okay, what's our need? Oh, well, how do we determine the efficiency of a sediment settling device for stormwater? That's an example. And then someone drafts up a proposal, how to do it. And then they form a technical committee. Now, the technical committee is E64. That's the larger group, and I'll talk a bit about that in a minute. But you also may have subcommittees. We have 4 subcommittees in the E64 group, and I'll explain them in a minute. Then you move into drafting, and that's usually the technical committee will break off into a smaller task group. It'll be the people that are really interested. You might get some researchers, you might get some suppliers, you might get a council person that's really interested in testing. So they make a smaller group, and they have lots of meetings, and they work out and they flesh out the language and everything, and then they all agree, they get consensus, and then it goes up to the subcommittee first, and that'll then vote on it. And again, you still need consensus, and then if it passes that, it'll go up to the main committee. So everyone who's a member of E64 gets the right to vote and add their comment on any standard that's been developed. During this consensus, you get to vote, as I said, the balloting, and if you don't like something in there and return a negative response, it is the group's responsibility to work with you, and it's your responsibility as a negative submitter to kind of suggest a solution that will work. There's an intent behind drafting a clause or a paragraph or a section, if you might not like something, so you need to work with the group. Now, there's a few rules there, but pretty much you have to have 100% agreement before it becomes a published standard, and that makes it so robust. Now, every 5 years, these standards are revised and updated if required, or at least checked and then put back into the catalogue. So when you go to the ASTM standard that it's the most latest and up-to-date standard and of the best practical knowledge for the current time. So no other kind of rules or anything developed by individuals can be constantly revised and up to date with the state of play. So into E64, stormwater control measures. Now, this is the latest and the newest ASTM committee. They don't create committees very often, but there was a real need for improved standards with stormwater control measures. So this is what's been created. There's 130 experts that have already joined this committee, and there's people from New Zealand, that's me, Germany, there's some from Australia, the UK, but the bulk of the people are from the US, which has been managing stormwater the longest of any country in the world. The US were the first country to bring in stormwater regulations. It includes a broad group of people, everything from researchers to regulators and consultants. So it's the best stormwater minds arguably in the world. What it does, and these are the little things I've taken from the scope of E64, is their goal is to create a framework that integrates both quantitative and qualitative assessment methods to look at innovative stormwater management. And it's good that it's quantitative as well as qualitative, because some of these things you can't necessarily measure. Like, how do you measure clogging on a screen? It can be tricky. Or so a lot of them, the tests are just observe and note the stuff, note the results, but some are very prescriptive on what's the number. It endeavours to really get the balance between technical rigour and practical application. Now, you could have a standard that's technically really correct, like we must really look at, the sub 10 micron particles or something like that, because that's got the highest pollutant concentration. But that might not be really practical from an actual lab sense or a field sense. So what the standards try to do is find the balance. It's not necessarily, all the technical expertise, best way of doing it, but there's no point in having a standard that can't be actually applied. It enables practitioners and decision makers to effectively evaluate and compare different stormwater management practices. And I think that's what we're all looking for. If technologies are all tested the same way, it creates a benchmarking system where you can have a look at the relative differences of them. So E64 has 4 subcommittees. There's a lab evaluation subcommittee, there's a field evaluation subcommittee, there's a component evaluation, and there's non-point control measures. That hasn't really started yet. Now, Seth touched on this. Lab evaluation is a very important thing. It's good for measuring hydraulics. It's good for measuring larger particles or actual solids. But it has limitations when it comes to things like dissolved heavy metals or other things that involve complex water chemistry. Those sort of pollutants and things can only really be evaluated with a field evaluation, but the lab evaluation provides a lot of meaningful information that you would need to understand how to design a treatment device. So it's really good that there's 2 pathways here, or two sets of standards being developed, one for lab and one for field. As I said, component evaluation, this will be looking at maybe for some solutions that are of a scale that you couldn't necessarily test in a lab. Like, you imagine trying to, if you have a very large filter, like it's the size of a warehouse, and you want to test its maximum bypass capacity, you're just not going to be able to do that in the field or in a lab, for example. So you might just look at the bypass structure and a component and evaluation. Currently, right now, most of the work in component evaluation is mainly being done on different sorts of filter media and developing the standards for doing column tests. So I'm just going to run through quickly some of these standards. So the first one that's been completed is terminology. As there's a lot of difference in terminology across the planet about stormwater issues. For instance, in the States, they call a hydrodynamic separator something that spins the water and drops the sediment on the ground. But in New Zealand, we tend to call a hydrodynamic separator a gross pollutant trap. In Australia, they actually have a different meaning for gross pollutant trap, but that's something that has a screen and captures everything over 5 millimeters in size. So it's really important that we standardize the terminology before we start, so we're all talking about the right thing. And the other completed standard that they've already published is the test sediment, the silica-based test sediment. When you do a lab test, you use a silica-based sediment. Now, this standard describes how you make the test sediment. It has a couple of examples here. It has a New Jersey particle size distribution, which is very similar to an Auckland particle size distribution. It has a 110 distribution, which is all focused around the 110 micron particle, and they do that because in the past a lot of companies used to test with this fine sediment. But it sets up a methodology with this standard you could develop any sort of particle size distribution you want, but it will be consistent with all other particle size distributions as far as its density, its shape, particles, etc. There's a methodology there to develop a locally specific sediment, if you wish. And then, as Seth mentioned, trash standard has now been completed. And that's largely as a response of California regulating trash control and having a requirement to certify trash devices. So we needed to develop a standard on how we would test trash devices. And that standard looks at how this a screening device might clog up, how it will resuspend particles if you get a very large storm, or even what size, whether it will capture a neutrally buoyant trash item, such as maybe a chocolate wrapper or something like that will float in the water column. There's a test to look at how you capture neutrally buoyant contaminants. The standards in progress, well, there's quite a few in progress, and I've broken them basically up into settling devices or hydrodynamic devices and then filters. And filters is a bit like the storm filter or the jellyfish or the old school way, the sand filter. They filter finer particles than necessarily a settling device. The tests that they use is one for looking at its efficiency. There's also a scour test, which is really important to make sure it doesn't resuspend and throw material out. And there's also a method of verification, the steps you have to go through. Some of these are old standards that they're upgrading into new standards. Same with the filters. It's very much one looking at the hydraulics, another one look at its verification and its scour. As I said, there's a couple more coming through, and one on a lot of work being done on columns. There's another one on microplastics testing, which is in response to car tire or tire crumb, which is a different density than normal stormwater sediment, so therefore harder to treat. And also the field protocol for using automatic samplers, because typically that's how we monitor in the field. So that's just a quick rush through of ASTM. Now I'm going to pose the question, so what do we do here in New Zealand? Do we need a testing program? Well, New Zealand Coastal and Freshwater Policy Statement pretty much says you can't degrade any of our waterways. Now, that's going to be really difficult as we try to grow our population, because as soon as you develop land, you're going to have an impact on the downstream waterways. So there's a real need for us to develop better technologies. We need a testing program in New Zealand because there has to be some sort of accountability and transparency over what we're using and why we're using it and whether that will achieve our outcomes. That's a requirement of law for all municipalities or city councils in New Zealand or regional councils. We have regionally specific stormwater issues. For instance, in the Waikato, parts of the Waikato, they have a requirement for phosphorus removal. In other parts of the country, dissolved zinc is the issue. So we really need a broader standards and to address all our site-specific and the issues or regionally specific issues. The testing data we need to have access to, our regulators needs to be broad enough to include these specific stormwater issues. And we also really need it because it's really complex and really difficult to evaluate a stormwater treatment device. You can't really go out and do one sample at the front and one sample at the back and look at it and say that's how it's going to work, because stormwater is so variable. The concentration, the particle size, the pollutants in the stormwater vary from site to site, storm to storm, and even within the storm it can vary. So it's very complex in doing the testing and evaluating the results you get. So we do need a bit of guidance on how to do this. we've been in New Zealand, we've been doing stormwater management for a long time, and there has been a bit of a history of developing technologies and evaluating technologies in New Zealand. It all started back in the 80s with the Auckland Regional Council, and they spent a lot of money, testing ponds, testing sand filters, and doing a lot of this work, and with academia too, to get an industry going and get better stormwater in New Zealand. It's a bit like what Seth was showing with the Valley of Death there in the middle. The ARC started it all, and we're somewhat in the Valley of Death in the moment because industry hasn't picked it up and kept it going. We saw the likes of NIWA and Landcare and Auckland University doing a lot of work for that regional council, but when the funding dried up when the regional council went, there wasn't a lot of money being spent on research. Canterbury University is still doing some great research, and Stormwater 360 has been working with them down there and looking at testing and developing better processes. But it's still quite limited. Now, as far as the approval systems going, Auckland Council really has the only formal approval system. About maybe 15 years ago, they tried to develop a standardized testing procedure. They called it PDEP, Proprietary Device Evaluation Program. But their biggest mistake was that they did it in isolation. They didn't use a collaborative approach. They had the regulator write research, a whole bunch of standards all around the world, and pull together and make a really good standard, and they put it out to public consultation, and people gave their comments, and they decided whether they wanted to use those comments or not, and then they published the standard. Then all the suppliers, which Stormwater 360 was one of them, decided to put their data in, and what they found is that no one could actually meet the standard. Because they hadn't developed their requirements and collaboration really with the industry and other bodies, they had this standard that was impossible to meet. So in the end, they actually dropped the whole standard, and they decided just to borrow an approval from overseas. So that's really not that robust. You really need to evaluate the performance and your context of your location. So just taking someone else's approval system might not be the best way unless you've done the work. Waikato Regional Council and Christchurch Regional City Council, they have similar standards to Auckland, where they really are, just looking at other people's approvals and not really considering their context. So while they're better than nothing, it's still not appropriate for their local area. And then you have Environment Canterbury and Environment BOP. And I hope nobody's on the call from this, but what they have a good approach from an overarching point of view, and maybe a technical rigor point of view, but from a practicality point of view, it doesn't really work. Now, they want effects-based monitoring in Canterbury and Bay of Plenty, and they're asking people to go out and grab one sample before a treatment device and one sample after a treatment device. And really, you can't tell a lot whether that device is working or not. So by just doing one sample before and one sample after, because of that variable nature I mentioned before. So their approval system there really isn't really leading to better outcomes, because it's not really measuring accurately what's going on. So what are our options in New Zealand? Well, we could develop our own program like Auckland Council tried to do many years ago. It didn't quite work. We could follow an adopted program, and that's really possible, but we would really need to look at the different programs and make sure we have one that's really suitable for every different region in New Zealand. We could look to join STEP, and at the moment it's just a US-based approach, but they're hoping to expand it, and maybe there's a place for something like Water New Zealand to join that. Or we could actually kind of look at the model that's happened in the US with STEP and ASTM and try to develop our own, try to replicate what STEP does, and we could look at the ASTM standards and bring them in to become New Zealand standards. And that's actually how a lot of New Zealand standards have been created, by looking at the American standards. What would be the benefit? Well, it would increase our knowledge base through international collaboration. It would give us consistency and transparency, which is really what everyone's looking for. It will allow councils with a lack of funding or capacity or expertise to really manage stormwater, that give them immediate access to the world's best practice and up-to-date best practice as well. It would create a pathway for innovation and industry development, so there is some goalposts to aim at and we could look forward. And it gives the opportunity, like Enviropod and Stormwater 360, to export our locally developed technologies to other parts in the world, because there would be an agreed method of testing. Our results would stand up overseas. So there's a lot of benefits there for New Zealand. Now, I'm probably hearing somebody, oh, well, why the Americans? Why do we want to follow the Americans? There's other standards. And there are. And there's British Water has developed standards. There's SquidEp out of Australia. And there's a German standard. But these are often very location specific, very much focused on stormwater in Australia or stormwater in Britain or stormwater in Germany. And you can obviously think about the climatic differences of those countries in New Zealand. New Zealand's very varied in its climatic conditions. And the US is actually, because they're doing a national protocol, it takes in all the variation that you get across the whole of the United States, its whole 50 states, from Alaska to Hawaii. The other international protocols, the British, the Australian and the German, weren't developed by consensus or a collaborative approach. Again, it was pretty much the British and the German were done by a body that made all the calls. It wasn't this consensus that was required. Also, they also look at different contaminants and different testing procedures. Like one good one here is that the British and the German one are lab-based protocols. They don't do anything in the field, and they try to look at heavy metal removal in a lab-based protocol, and they use some metal salts like zinc chloride. Now, we've done a bit of zinc chloride, and they mix it up in water and they test it. But in reality, zinc in dissolved form isn't the only contaminant in stormwater. There's a whole bunch of other contaminants in there that also affect the water chemistry. So you can't really construct a lab test for something like dissolved metals because it's so complex in the field. So that test is really meaningless. You do a metal salt test, you'll get 90% removal pretty easily through any filter media. When you go out into the field, it'll drop to 40 to 50%. And there's also the big different challenges that we have. There's quite a lot of difference in definitions and the requirements in each of these standards, these other international protocols. And really, to move this whole industry and this global industry forward, we need one way of doing it. Otherwise, we're all talking different languages. So this is just a little throwing it out there. How could we develop it, our protocol ourselves or our system ourselves? Well, we could obviously, Water New Zealand is a great vehicle for pulling something like this, and Engineering New Zealand, but we could bring in universities and businesses. We could bring in brands, the Building and Research Association of New Zealand, which also do product testing currently into the fold here, because they would be a perfect administrator. We could develop our own New Zealand standards, and we could just basically pick up the ASTM standards, set up a New Zealand Standards Committee, which is pretty much run the same way as ASTM. And we could get all interested parties to contribute, and we could come up with a New Zealand standard that would be very robust and it wouldn't take as much work because there's already an American one to do. Water New Zealand could definitely supply the board of external reviewers, such like STEP has. But certifications and approvals would still lie with the regional councils or the water entities if they exist anymore. So that's just a bit of an idea on how we could run it in New Zealand. So there we go. Over to you, Matt.
Great, thanks, Mike. And of course, if there are any questions through this, please do put them in the chat. I suspect, will be some questions. And first one to begin with, Seth, I'm going to welcome you back because I have I have a question I'd like to ask you first. You set up and you managed to achieve what you did in the States. and there's many more moving parts, and you've managed to secure funding as well. So what's the main takeaway from setting up that National Stormwater Alliance in the States, and the main takeaway from then having a sustainable funding source to continue that work going forward?
Okay, for our nonprofit, the National Municipal Stormwater Alliance, I guess the takeaway there is that the first thing we did is we wanted to show, before we even got STEP going, we wanted to show a proof of or value of even existing. So the point is that we just did a fair amount of sweat equity up front to show that we're worth investing in. So there's that period of time where you just have to work your ass off, and show value. And once that happens, then we've been starting to get more and more membership and more support that way. And that also gave other organizations the confidence for us to take on STEP. And since we took STEP on, which again, it had been, the STEP program had been something that was started with the Water Environment Federation, but it was kind of lingering, languishing, as maybe is a better word. Wasn't really well funded, well supported. And so we said, we're going to take it and we're going to really ramp it up, because we got to do something, or just disband the whole thing, because it's been 10 years. It's a long time for people to invest, wait for something to happen. So we accelerated that, and we've made it into a true project where we said, hey, we're going to meet these milestones. And I think we've been accountable. Some things we've been able to hit, some things we've not been able to hit, but we've provided reasons about why we have been why we haven't been able to do that. We're trying to just be more kind of service oriented and make sure that we're accountable with meeting our milestones. And I think that's given industry, who's supporting most of the STEP program, confidence that we're actually going to be we're going to get this done, that we're worth investing in. So we do have a number of municipalities that are just leaders, and the other takeaway I would say is that if you show accountability, people are going to be more motivated to actually invest in you. And I think the other thing is that there are champions in the public sector out there that will invest money. That happens all the time. I'm always surprised by leaders within cities and communities that find a way to provide support. So having that grassroots organic funding is great, and that's going to help us now get, I think, more funding even from the federal government. We're seeing that happen. So I just think you got to start making progress and show that you're making progress and be accountable. And I think you can develop confidence, and people will start investing money in your program. That's the approach we've taken so far.
Great. No, it's good to hear, and it's good to reflect on how that might apply to the model that's currently in New Zealand. Something else, Seth, that I was quite interested in by how you set up STEP is that it's not just about products, it's about practices as well. And the verification of the practices and their performance, and how do you test and manage, I guess, around the quality assurance of the construction, of the design of those open source devices. And it's something that Bradley mentioned about in his question, because we often look at the International Stormwater BMP database, and that does a similar thing, as it looks at manufactured devices as well as open source devices. How does your work fit in, say, with what the BMP database is doing?
Yeah, just real quickly, the principle, and I'm trying to rush through it, but I think an important principle that I didn't really focus on that I'd like to mention here is that a foundational, it was something that we decided from day one in this program, is that we need to care about the performance of all infrastructure, whether it's something that's proprietary or something not. Why should that matter? And there's been, I think, it's been a lack of equity. Why is it that there should be more parity, is the point. Manufacturers shouldn't be the only one who are burdened with testing. I think it's an opportunity. I'm not saying we should get away with testing. I think we should just test everything and find a way. So obviously it can be a little bit different, but the point is we need to have some more equity and parity between the proprietary and non-proprietary systems. So that's just a foundational aspect of this, and through that, to make that happen, we need to make sure that as we talked, as Michael talked about the ASTM, we're really working to get researchers involved, the folks who are leading the basic research on things like, as an example, ponds. I'm from the state of Minnesota, up in the northern part of the U.S. They call it the land of 10,000 lakes. There's actually 13,000 lakes, and there's and for stormwater folks, it's 50,000 stormwater ponds. There's just, it's everywhere, and so there's a lot of ponds are used a lot in stormwater management. You use what's local, right, to your advantage. But they're showing there's a lot of research being done that's showing that ponds are not performing as they were expected to, and now they're starting to export dissolved phosphorus, which is as opposed to particulate bound phosphorus. Well, and they're coming up with the factors. There's certain ages, there's certain characteristics that this is. The point is now we're those researchers, we can take the research they're doing and the methods that they're using to develop some kind of understanding of how we can standardize how we measure pond performance. What does it matter if a pond's in New Zealand or Minnesota or North Carolina? A pond's really a pond. Obviously, there are different configurations and whatnot, but as Michael talked about, if we can standardize that, then all the better. So the point is, it shouldn't matter whether or not it's proprietary or non-proprietary. We need to measure everything that's out there, and I think to me that's the kind of the holy grail for all of this. So we have a better sense of performance writ large in our sector that provides confidence. I don't know if that answered everything in that question. Is there something that I missed? Then let me know. I feel like there's something.
No,
else
it's good. And
okay.
Brad, you know where we are. So if you've got any other questions,
I can chat to you.
We can chat to that.
BMP waterways.
Got a question.
Yeah.
Question now that kind of similar joint question between Ali and Linda, and this is one for Mike from the New Zealand context. Is Linda's asked whether the water reform is an opportunity to develop a New Zealand-wide set of standards, and I guess it kind of is in the sense that there is an engineering code of practice that's, a national engineering code of practice that's being looked at and explored, but it's a bit more limited in its approach, and granted it's at an early stage of its outset rather than a fully fledged standard for testing. But whether you see there being an opportunity there, and whether you, Mike, what Ali's asked is in support of a nationwide standard for stormwater devices assessment, selection, testing, approval, or whether that then needs to be geographically based. So kind of linked in is there an opportunity within reform to develop something that's nationwide, but then how nationwide do you go? Do we still need to have a more local approach to assessing the effects and the outcomes?
Sure. I think they're both really good questions. Now, I definitely think we're need a nationwide approach, and this is the time with water reform. I mentioned we need innovation, so there has to be a pathway for innovation. There needs to be a way to develop these ideas that I'm sure lots of people on this call have, and actually see if they work and see if we can deliver them time after time after time again. So there is a need for a national-wide process. And I say that as a process. I still believe in this verification and certification approach. Now, I think we should have a national program that lists how we test, what the requirements are. We have one national body that does the evaluation and verifies the results. But really, under the RMA, the responsibility of water lies firmly with the regional councils. Now, they need good quality information they can trust to look at, and that's where the verified data comes in. But that the testing needs to be broad enough and include enough that the regulator can go, oh yes, I've got a specific problem in my location, such as I mentioned, Waikato might have a phosphorus issue. We want this data in the device, or we want this performance. So there is still a role for approvals on a geographical level. Maybe you could amalgamate a couple of the regions to save on the burden with that, but it still has to be approved at a more of a local level. But the actual testing and the procedures and the standards, what concentration should we test at, that can all be worked out on a national level. And definitely the evaluation and the verification can be done on a national level. So yes, I believe it should happen and with water reform and nationally, but that approval still lies with the regional councils, and the accountability and the responsibility lies with the regional council.
And it's always a very interesting one within New Zealand, because you have the regional council that's responsible for the outcome, but then the territorial authorities that are responsible for kind of the operation, and then the managing of the devices and configuration of devices that go in. And there are, some places like Waikato with the POLAB, they have a local shared services group. So they're trying to, again, at the territorial level, go, let's work together to achieve this. And I guess, Linda, in relation to water reform, we will find out what that's going to look like in the next few weeks, hopefully, maybe a couple of months.
6 months.
And I think I saw Gillian did a podcast for, I think it was Stuff News, just calling for some Water New Zealand calling for some certainty for what's going forward, because and that's where what Mike is saying is, it's not, we're at a time where we don't quite know what's the best way forward. And here is an excellent standard. Here we can take the work that Seth has done, take the model that Seth has pulled together, and see how that might apply to New Zealand as we go forward.
I think developing a standard around maintenance, frequencies, and service life would be also something that ASTM, I know that Washington's looking at it now. If we brought that in, that would really help a city council who has to decide whether they're going to accept an asset for vesting, whether they want it or not. And if a test has been done to that standard, they know every product's tested to that standard, they have the confidence to go, yes, we're going to accept it, or no, they don't. So again, we can develop a standard to suit everyone.
Well, thank you, Seth, especially. It's now relatively late in your evening there. It's been a pleasure to get to meet you. I know you work quite closely with Mike, but it's been a real pleasure to hear about the work that you've done in the States, and specifically the fact that our problems are similar problems in the States, and you're just slightly further down that journey. So it's also reassuring to hear that there's a pathway through. So thank you very much for sharing your knowledge and expertise throughout this process. Thank you, Mike, for joining us as well, and sharing your knowledge of the work that you've done with Enviropod in going through the ASTM process and STEP process, and testing overseas, and bringing that back to New Zealand and how you might apply it here. So thank you for your time, and thank you all for joining. There's still a few people on. We've run slightly over with the Q&As, but that always happens. Always happens. We'll be sending out a link to the webinar for those that registered and signed up. So if you missed it, or if there's someone else who you think might be interested, or if you're got a handy contact at a local council that you think should see some of this information, then you'll be able to flick that onto them. Thank you all for joining, and look forward to seeing you for our next webinar.
Great. Thanks a lot.
Brilliant.
Thanks a lot, everybody.
Thank you, guys.
Cheers, Seth.